NumPy Datatypes. NumPy supports a much greater variety of numerical types than Python does. First, there are primitive types that are supposed to be related to C, which are these. We can clearly see np.bool, byte, ubyte, short, long, signed character, unsigned character. This can be easily seen in C, and hence it is related to that, and it depends on platform. So these are platform defined data type. Others are platform dependent definitions like int8, which has only 8 bit, 16 has 16 bits, and similarly 32 has 32 bits, and the range of objects is varied from data type to data type. Then there is int_p, which is the type for integers used for indexing. So NumPy numerical types are instances of dtype objects, hence we will see numpy.dtype commands and functions when we go to examples.
Now we'll look to the examples. First, we need to learn to create NumPy arrays. There are many ways to initialize them, and we'll look at most of them. So let me open the Python shell, importing NumPy as NP. So I import NumPy as NP because when I use to write commands, I don't need to write NumPy, I just write NP. I could have worked with NumPy also, but NP is short. But so the first way that we are going to learn is np.array. NP array is useful when you want to define the array element by element. Let me just find a one-dimensional array. And here it is. You just need to write np.array and then give first parenthesis and then give the array as you want. So here I'm going for a two-dimensional array. I just want you to have a look at the structure that I have made. First, I've given a parenthesis, then a square brackets, then another square brackets into which the first row is there, then second row, and then one square bracket, and then next. If there were more dimensions, then I would have put 3 parentheses. And here it is. Now let us move to another examples. np.zeros. What if you want to initialize an array with each element as being 0? So over here I need to give the size of the array only. I don't need to specify anything, and this will give me a 0 array. np.0. Now if you want a multi-dimensional array, you can do it with another parenthesis where you can mention the shape. 4,5 is the shape of the, sorry, I wrote AP. The error was here actually, this, just to clarify. Yeah, we got this here. Similarly for 3-dimensional array, and so on. Let me just resize this a minute. Now if I wanted 1 instead of zeros, surely in case of multiplication, when you need to multiply something, it's better to have 1 than 0. So here it is. I just need to write ones instead of zeros, and similar to zeros, everything is same, all the syntax is same. You just have to write ones instead of zeros, that's it. So we move next. What if we want to initialize random values in array? You don't want to define each and everything. Say the array is very large and it has to be randomized. So there is a command called random.random. Over here you just need to write the size like above all, and here it will give you random values. This is 4-dimensional array that I just made. But you would have noticed one thing. all the values are between 0 and 1. 0.34, 0.24, 0.41. What if I want an integer? So there's a command np.random.randint. You can coordinate if you have done the random library in Python. But here the syntax is not according to random.random. Syntax is a little bit changed. Here I need to write the range first. The range between which the number has to be. So I'm choosing the range as 1 to 10. And then I need to write the size. So these are all the number between 1 to 10 and the size is 10. I can also make this 1 to 10 only, and I can give it any shape. Yeah, if you have any confusion with the size I wrote size here just to explain you, and this is also a correct concept to write. And I could have written size over here also, but better for me to write in this way. Like, let me just show you so that there's no confusion. This also works, and in fact size can work here also, wherever the size has to be mentioned. Now what if you want to have a pattern in distribution instead of randomizing it or having it zeros or ones? So here the solution is with a command called np.linspace. Here we need to put the values like we have done in random, and then we need to write the size, not the way to write. Yeah, so this is the size over here, and this is the range. Here it is. So the range of numbers are 1 to 10 and the size is 5. So this is evenly distributed. The differences are same between each number. So here is difference of 2.25, another difference of 2.25, then difference of 2.25, then 10. Similarly, if I want to make a number, actually this we need to be careful whenever we write this space, that we don't have to write e. It's linspace, not 9 space. So there's a difference of 11 in each element. 1, 12, 1 plus 11, 12, 12. The way to calculate the difference is to do 100 minus 1 divided by 10. Easy. 100 minus 1 divided by 10. So these were the ways to initialize a NumPy array. Indexing. Indexing of 1D array is same as indexing in list. So here we can see a 1D array, and the index given is started from 0 to 1, 2, 3, 4, and backward indexing has started from -1. However, when we go to 2D arrays, the indexing becomes quite complicated. These 2D arrays are also found in list, but when we actually code, we learn that accessing elements from NumPy array has different syntax than accessing from list. So here we can see that the indexes are 0, 1, 2 and 0, 1, 2 over here, and this is simple coordinate system idea, and it's 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2. And similarly, like 1D arrays, here are negative elements, negative indexes also, like -1, -2 and this one. So 9 refers to 2, 2 as well as -1, -1, and 1 refers to -3, -3 as well as 0, 02. Let's get our hands on the code. Import NumPy as np. Let me define a one-dimensional array first. Wanted go round array x equals to np dot one, 2, 3, 4, 6. Here it is. Now to check indexing, we need to do this. X
We need to write the indexes in the square brackets. That is how you get your elements. Also, let me check. Yeah. Also, we can also do it by backward indexing, and we'll get the elements as it is. Okay, x equals to -1. I'll get the last element, and this is how it works. Now let us define a two-dimensional array. One more bracket, and it is defined. Okay, so what the I forgot to put the commas over here. So here I made the two-dimensional array, and this array is the same as I have made here. I made this figure just to represent a two-dimensional 3x3 array. Let us move on. So I can do x equals to 1 and I still get the output, but it will be an array because technically 4, 5, 6 itself is an array in a array. See, 1, 2, 3 is one array, 4, 5, 6 is one another array, and 7, 8, 9 is the third array. So these are element of one array itself, if you see it that way. And for getting the exact value, for example, I need to extract 4. So if I were to use a list, I would do this, but this is not a list, this is a NumPy array. It uses 1, 0, and this is how I get it. Similarly, x 1, 1, I'll get 5. This is also true for negative indexes too. X minus 2, minus 1. So if I were to write x 3, 3, it would be wrong. But writing minus 3, 3 is right, because positive indexing starts from 0 while negative indexing starts from -1. So 3 is valid over here, but 3 is not valid in positive indexing. Slicing. Slicing is very important tool in NumPy processing and NumPy manipulation. Slicing is used to extract a part of the array. This is also used in Python list also, and some syntax of using slicing is similar to Python list. Import NumPy as np x equals to np.array. Now this is going to be 1D array only. Okay, so I need to slice 2 to 4 only. So I'll just write the lower range and the upper range. That is 4. The upper range needs to be one value more than the required index. For example, I needed 4. I need is 4. So I will take 4, which is at index 3. So I'll take the index 4. That is why I'm taking the index 4. Here, 2 to 4. X 3. But there's one more syntax to write from 0. That is this. This will give me the same result only. Okay, so yep, one more concept is I can do this with minus 3 to -1. What does this do? Let us see. It gives me 3 to 4. That means -3 is 3 only, because it's -1, -2, -3. And since -1 index won't be included, hence 3 and 4 are printed. So we can also use negative index as well as positive index for slicing too. Since this number 5 is at the position or index 4, hence the 5 is printed over here. Okay, if I would have written -3, 4, oh sorry, not comma. Yep, 3 comma 4, it would have given me the same result as -3 to -4. And let us make a 2D array missing comma. Yep. Silly mistakes. So just let take out that figure that I have made. Now what if I do it like this? 1 2 3. This is what I get. So I get 1 and I get 2, because as I have mentioned earlier, these are an array in an array. So this one is an array, this one is a second array, this one is third array. So it has just picked up the array and given me a part of that array. So this has given me this. But what if I need a specific portion of an array? For example, this portion. So we can get this using slicing. So this is 1 2 3, but this is, so what if I need this portion of the area? 2 3 5 6. So x 1 2 3 comma 0 to 2. Okay, because this is 0 and this is 1, but since in the upper limit an increment of 1 has to be done, this is why 2. Okay, this there has been space. Write it actually. There has been a space. So here's this what we needed. So I got this for 4.578. Okay, to get 2 3 4 5 6, we need to do is we need to interchange this. Yeah, we have it 2 3 5 6. So in this I can also use negative indexing 2. Here it is. So -3 to -2, -3 and -2 I'll get. Maybe what if I need this 5 6 8 9, -2 to -1, -2 to -1. Wait a minute, but -1 is this, that means I'll only get 5 and 8. So do I need to write 0 also? Because technically you increment here a 0 here, that is what you get. So it should be this. No, it will give you a error because 0 is this now. What can be done in this situation is -2 to 3 comma -2 to 3. You cannot use 0 over here because then it will go backwards. Okay, because this is 0 according to this, but according to this is 2. So this is all about slicing. Indexing. So we have done indexing and slicing. If you have worked with lists in Python, then you must have noticed these concepts are very much similar to the lists that we have done in Python. However, advanced indexing is the out-of-box thinking that makes NumPy so much more powerful. It has two parts: purely integer indexing and Boolean indexing. When integers are used for indexing, purely integer indexing is used. It is used when we need to randomly extract elements from different parts of the array. In slicing, we extracted a part of the array, but here we are extracting from random places. In purely integer indexing, we write the dimensions separately. So in this example that is mentioned over here, since this is a two-dimensional array, there are two dimensions separated from each other. So if I want to process this 9 under print, I simply need to pair both the dimensions.
0, 0 gives me 1. 1, 0 gives me 3. 2, 1 gives me 6. Let us learn this with codes. There was an extra R. So I got 1, 3, 6. Okay, so let us try with another example. So this is a 3, 3, 3 three-dimensional array. So this is the array, and let's get some random values that I want. So here I got 9, 1. So 0, 1, 2. 0 is first matrix, 1 is the first row, and 1 is the second row, and 2 is the third column, that is 9. 2 is the last matrix, 1 is the middle row, and 1 is the middle column, that is 1. So we got this. Now let us learn about Boolean indexing. Boolean indexing is used when we want to extract elements based on a condition. In this example, we are extracting all the number that is greater than 50. Let us try this on the codes. Okay, so here I've written the code and I got 80, 100. 80 is greater than 50 and 100 is greater than. What if I wrote A is greater than equal to 50? Yep, I got 50 also. We'll do another example on this. This is the array A, and the objective is to find the square of every even number. So it's simple. A modulo 2 equals to 0. A modulo 2 is used to check if the remainder is 0. If it's divisible by 2, then the remainder will be 0. If not divisible by 2, then the remainder will be 1. Simple mathematics. Then we write at the power 2. So this is used for the power of. Okay. Here I got all the elements. 78 is 6084, 36 is 1296, and so on. So this is advanced indexing, very useful concepts, and it can help you solve a lot of problems. Thank you for watching the video. If this video has helped you, please give a thumbs up. And if you're into Python, algorithm, machine learning, neural network, and AI, this page is for you. Please subscribe the page Think Now, as making better content every day.